Yes, here we are. Hey, welcome everybody. Welcome once again to Astronomy Daily Live. So, yeah, I'm back in the office. I guess you could call this an office of some sort. Yeah, it's cloudy again. We got those high, thin clouds out there. So, and I said I was going to start at 2:15, but I'm ready to go. I was running a little bit late, and as you know, and if you don't know, um, you're you're hearing it now. I the One of the things that I avoid at almost all cost is hurrying. Is needing to hurry in any way, right? I I would rather not do whatever I have to hurry up and do, or if there's no way avoiding it, then I will not do the next thing, you know, and that's sort of what this is like here. So it's running a little bit late, had to get some dinner, and wanted to make sure that I wasn't hurrying at all. So it's extremely easy to say, hey, running a little bit late, going to start the live stream a little tiny bit late. No, no big deal. I hope you know by now that here I'm trying to encourage a casualness that's just we we can sort of be ourselves here, and that's just how I like it. So there's the only thing that I'm really doing different, um, that I haven't been doing for years and years and years and years, is instead of thinking, just thinking these thoughts, I'm blasting them out there, right, to you and to the universe. So, and that's our primary means of communications, right? Is that. So that's exactly what is going on, and so yeah, that's really the only difference. Is that you're sort of hearing my thoughts, right? I'm thinking, and then I'm just sort of relaying those to you. But yeah, we're extremely casual here. That's partly because that's just how I am, but also it is a daily live stream, so I don't feel rushed to do anything at all. And there is so much when it comes to astronomy and space and science that there is no way that that anyone is ever going to cover every single topic, every single nuance, every single detail. Um, so instead of being in a mad rush to try to pack in as much information as possible and all that, let's just sit back and just enjoy this a little bit. And part of um, um, the enjoyment I get is trying to understand, what's going on and why and who and where and when, all the W's, right? So yeah, and that feeds my curiosity, which is one of the foundation legs of science. You got to be curious. If you don't care, then then um, um, you're basically accepting it, and you know the, that's all. But if it's like, why, how is it right? How is it that I can fill this mug, this dirty mug, um, with a cold liquid, put it in a box, close the door, push a button, and a minute later, it is so hot I can't even touch it. How does that work? That's amazing, right? I think it's amazing. But, you know, we have figured that out. And it's, you know, I mean, it isn't simple, right? The explanation um, for those kinds of things are, you know, years and years and years in the making, lifetimes. But now we just have to push a button and we get our hot coffee. So cheers. I've got a little bit of this left. And before I keep going, definitely want to say howdy to Bobby on the panel.
Yeah, well, the things you said, it comes with this song. It's the ropes and the lanes and all the things, all the little thing called the rodeo by Garth Brooks.
Oh, okay. Yeah, I don't know if I've ever heard that one, but Garth Brooks is.
If you was raised in '90s country, you definitely would know Garth Brooks.
Well, I definitely know the name, and I do remember when he was extremely popular. I was well, at least a young adult by then.
Yep.
So yeah.
Okay, so Uncle Bill Thurman, welcome. Jim from Carolina Sky, all right. Deep Sky Dew and Chuck Nam and Nicole. All right.
Deep Sky Duty's here. Good. Yeah, we've got a house. Well, I'm really, really glad to see everybody. I wanted to say some things about yesterday's OBS session. And, you know, this is my way of sort of critiquing my work / behavior, and also showing you some results if I have them. And I do have some pretty cool preliminary results. So last night, once again, I broke my own rules in terms of protocol, and you know how I was going to deal with not being able to find a target. Okay, I you know, there's this big huge voice back here that while I'm trying to find the target, yeah, while I'm trying, you know, to match the star field that I see from the sky to the chart that I'm trying to figure out where exactly, you know, the telescope is pointing. You know, there's this voice in the back of my head that's saying, it's probably there, but you're not seeing it. It's probably there, but you're just, you know, way too blind. You just, you know, you can't do this stuff, right? And so
sometimes it'd be much better if you had like those ASO TV programs like the night vision and the HD vision and stuff. But I do want to show you that I actually got myself a brand new phone today.
Oh wow, yeah. Let's take a look. What is this?
Okay. This is the TCL XL, I think it is.
And there I am. I see me on the screen.
Yep. And and I just tried out some cool features like the OSV OTG. So let me see if I can. There it is. So I can do this and plug it up to my phone, and I can enjoy the radio. I was listening to my marine traffic.
Very cool.
And in the baseball.
I guess it has to go through the smartphone so you can pick
It
up
has
the
to go to the
audio, right?
charger port. It has to go to the charger port.
It needs power too. Okay.
Yeah.
So it needs power, and of course you listen to the audio through the
Yeah, that's it.
smartphone, right? Very
Yeah.
cool.
And you ever heard of Miracast?
Who?
The Miracast is like it uses like the Wi-Fi direct, and it allows me to like directly push my display and the sound to a like a Roku or Fire Stick without needing the internet.
Wow, very, very cool.
Yeah, yeah.
Interesting.
I had a Miracast dongle one time when I had my Dell Bing Pro, but I haven't been using it for a while, and I'm not sure if it needs to be updated or something. But I don't have. But I wish Microsoft creates a app that allows you to update the dongle, because that's the only thing you're going to have to do it. So, but with my Fire Stick and my Roku, I can push the screen to my TV, and I can just do whatever I want.
Gee, that's
Yeah.
you know, it's really amazing. You know, I'm old enough now to start sort of being aware of change.
Yeah.
And one of the really amazing things is how these little devices of ours have really they've I think they've sort of pushed us to innovate and do some pretty interesting things. Not all of it is incredibly useful, but it's at least clever. So
and that's it. That's it.
I like it.
My old ZTE, the screen was getting weak.
Yeah, that happens. That happens. You turn the brightness all the way up and all that.
I usually put my brightness at max.
Oh, okay. All right.
Yeah.
So it was already all the way up.
Android Oreo on this one.
Android Oreo? Yeah.
Yeah. Android 8.
Yeah.
Yeah. So, yeah,
I think that's what I've got.
I'm having a blast with this phone.
Cool.
And I just
it's amazing.
When I click on the home key, let me show you on this YouTube feed. When I click on the home,
right.
I can have a picture-in-picture. I can even do this.
Wow.
And put you back on the app.
Wow. Very cool.
So that's another cool thing I love.
Very cool. Yeah, you know, that's one thing that I when I got this phone a couple years ago. I mean, it's actually been a couple years now. I thought, yeah, you know, this is a great opportunity to start writing, you know, apps, right? Learning how to do that, and I've never gotten around to it, and partially it's mainly because I don't know. I haven't had the motivation, you know, to get into that. It's a pretty interesting area. It's all it's written in Java, which of course is really nice because that is.
So Tom Van School's got in on this day in history. The Sayat 2 space station launched from Baikonur. No crew ever visited the station as it encountered problems in its first 2 weeks in orbit. Some reports say there was an explosion. The result was that the station lost altitude control and depressurized, making it unusable. It re-entered in May 28, 1973.
Wow. Yeah, you know, Tom, I was looking at that, and I had absolutely no idea that was a thing. I've never heard. you know, I mean, who am I, right? I mean, I don't hear
I
everything.
mostly like remember Skylab and stuff. I heard Skylab was the bomb.
Well, Skylab had its weird problems too, and you know, it was basically just, I think, right. I think it was like a modified third stage of Saturn V or something like that, or a middle stage. I forget exactly, but yeah, that was Skylab was launched. Man, I want to say it was after Apollo, so I think it was like 74, 75. I remember when Skylab burned up in the atmosphere. Yeah, that's um, uh, there was a big rage about that. Everybody
Yeah.
was very, very excited, and
Yeah.
one of
Now,
friends.
now speaking of space stations,
Yeah,
does like NASA? It's not NASA's not planning on abandoning the space station project as of yet, right?
I think I think everybody, the Americans and the Russians, I think are good to at least 2024.
Okay, so you can say about 5 more years.
But look, you know, I think that they should sell it. I think they should sell it. Get somebody up there who isn't NASA, you know, who's not the United States, who's not Russia, who's not anybody. Get somebody to buy it, and then you know, keep it as a lab, you know, or you know, I mean, it basically is a national lab now. That's more or less what it is. But I mean, of course, it's much more than that. But yeah, when Skylab was coming down, one of my friends had a T-shirt that had a red bullseye on it that said Skylab, right? Because everybody wanted to see it, and I don't remember the details about its crash landing. I want to say Southern Pacific. I want to say that people in Australia saw it, but I don't remember. Um, um, yeah, well, Tom, don't I look? The space station, the International Space Station, is definitely there. I mean, I would have. I'd be extremely surprised if the military didn't have, you know, some kind of finger uh, or toe on board the space station in some way. So yeah, that's not really anything new at all. But you know, I
Yeah.
mean, you know, we think that we have to fight, and you know, we have to keep secrets, and you know, and so if we think that way, then we have to spy on each other, because that's the only way to find out what we're doing, right?
Yep.
We either
That's why we got number stations.
yeah, you know, we can either tell each other, um, uh, or we can spy on each other. We're going to find out one way or another.
Ooh.
Anyway,
Yeah.
so
Did you know there are some hybrid digital voice or just voice or and just digital when it comes to number stations?
oh, that's kind of interesting. Do you have to
Yeah,
decode it?
and I think now speaking of when it comes to decoding, you need like special software. For
Right.
SPA2, you need something called Ribbit, and for HM01, you get something called dictrix. Now, let me tell you something about dictrix. Sometimes you can make it work, but then there will be times where it will just crash.
Huh.
Now, sometimes it may not be the best because when you do using dictrix to decode the HM01, it's all pseudo random gibberish crap.
Right.
Yeah, so it's good to decode HM01 data, but you're not going to get anything out of it.
Okay. Well, anyway, let me.
But XPA2, you use Ribbit, and it does a good job.
Yeah. Texas Star Party. Yeah, that I hear is a good one, and yeah, I think if you can go, definitely go. I
don't know. My people don't want me to be out of the state.
Yeah, that's all right. Star parties are really, really fun, and there are sort of there are different levels of star parties. The Texas star party is it's probably not the largest in the world or the country, but it's one of the larger ones, and it's been going on for years and years and years. And this is this isn't necessarily a public star party. Everyone's invited, but and I don't know exactly what the accommodations are there, but oftentimes, those kinds of star parties, they're out in the dark, and these are serious amateurs having a blast, right? Having an absolute blast. But they want their dark sky and all that. But oftentimes you have to camp, and so it's not really for the public per se, but anybody can go, right? So
I kind of like camping and stuff.
Cool.
I went camping at my best camping experience is usually at Chico in Brownville Platte, Louisiana.
Very cool. Yeah, when I was a kid, teenager, I went to a lot of dark site star parties. There was one up in Washington State, so that's where I'm originally from.
I love to go back to do some camping and maybe do some canoeing. I love canoeing.
Oh, really? That's cool.
Yeah.
Anyway, so up in Washington State, it was called the Table Mountain Star Party, and it is an annual thing even now, but it's much changed. Back when I was going up there in the mid '80s, there were maybe 10 of us, maybe 20. That was huge. So there were more like 10 of us or a dozen or so, and we had the whole top of the mountain to ourselves. It was just this great spot, nice and dark and everything. Table Mountain now I think is several hundred people there, and vendors, and it's I will definitely never go back to that at all. And large star parties like that.
Going so soon, Jim?
See you later, Jim. If you must, you must. All right. Anyway, I want to get back to
another Bluetooth speaker because my Q speaker went out today. It's only $6 and stuff like that, and it works like a charm too.
Great. That's awesome. That's very awesome. Okay. Well, let me get back to the OBS session because there's always way too much to talk about. So anyway, so yeah, I broke my rule, my 10 or 15-minute rule. If I when I don't find a target within 15 minutes max, then I move on to the next one. And if that next one encounters, if I encounter the same problem, then I can't tell myself that it's me, because that's what I do. Like, oh, it's got to be there, and you're just not seeing it, right? So I've got to get out of that mentality and just assume that the telescope, for whatever reason, is not pointing very well. And after I ended the live stream yesterday, I did just that. Like, let's see how well this thing is pointing. And so I pointed it to a bright star that I could see through the finder scope. And lo and behold, it was way off, just way, way, way off. And it's very, very likely that the extremely obvious star patterns that I was seeing on the screen were just off the field of view of my chart. So either I need to widen my chart, or I need to make sure that the telescope is pointing better. And I think I'm going to do the latter, because widening my chart, I don't want to have to start, way, way, way over and have to move in on a target. I want to be fairly close. So yeah, that, but I was just, last night I wasn't too worried because there was some wind. So I wasn't.
It's like, thank goodness that your telescope was not going to see us days, or your camera's not going to see us days yet.
Oh, definitely. Well, here's hoping, at least. It's any either the camera is going to go or the computer is going to go. Either one of those will. Well, if the computer goes, I can probably recover. If the camera goes, I am out. I am out, at least until I can get a new camera. So,
yeah,
but
and you did say that the cheapest is about 1,000, right?
I haven't really even looked at that. So I am not interested in cheap. I'm interested in good quality. So I can't go cheap when it comes to what I'm doing. This telescope is pretty darn cheap, and that's about as low as I'm going to go.
Now, I remember when you used to do it with your webcam. Is that still an option or no?
Well, I think what I'm going to do with the webcam, when there's some kind of interesting event, probably what I'll do is I'll pull out this guy, and I'll put the webcam on there, and we'll probably watch the event with this guy. But yeah, I don't. We should probably think about doing that again. There's just, I'm fairly limited when it comes to what can be seen with that webcam. So you've got the moon, you've got the planets, and maybe some bright stars. But there's no way to see galaxies or nebulae, or really even clusters, because the stars are just too faint.
Now, let's say on that great scope, you can modify it so that you can do your CCD Can you do that?
Mm, no, this mount is even uh, 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 well, weaker is the wrong term, but it's actually much weaker than that one is, and this one is
Uh,
struggling a little bit. So yeah. Plus, there isn't enough. I don't think that there's enough room. Um, well, yeah,
so,
there might be enough room there. Um,
okay.
but yeah,
So,
that's not really an option.
yeah. So at any time if it gets like to this weakest point, it's gonna break, right?
Um, what's going to break? Huh?
Your telescope is your telescope gonna break at any time?
I hope not. It shouldn't. It shouldn't. I'm not. I am treating this like a newborn baby. Just you know,
Mm.
coddling it
Yeah.
and
Thank God it doesn't break your back yet.
no.
Uh,
It's kind of interesting. I've got the camera sort of pseudo permanently mounted on there, so I don't always have to take calibration data. So I can take calibration data from time to time. I don't have to every single observing session.
okay.
And um, ever since I put that on, okay, that thing weighs 3 pounds. So I mean, it's not a lot, but
Now, can you get lighter weight CCT cameras?
oh yes, today's um, CCD CCD cameras are half that weight, and maybe even less. So, oh yeah, absolutely,
And may have that USB 3 and stuff.
absolutely, and that would improve
Yeah.
things as well. Who knows? Maybe someday. Anyway, because I'm so paranoid about bumping this thing, it feels like the whole thing weighs about twice as much as what it did, because
Alright.
I'm being so careful. Anyway, so yeah, uh, what I should have done much earlier in the observing session is stop and look at the pointing, look carefully at the pointing. I would have realized that the pointing was way off, and instead of spending almost an hour, I spent almost an hour looking for that dumb thing, and the maximum, uh, if I would have just realigned, is like half an hour. So, and I would have gotten data too. I spent an hour and I didn't get anything. so so I can't break my own rules. That's just not allowed. It's not
Yeah, that's
allowed.
out of bounds right there.
That's right. Anyway, so after the Messier 65 failure, I the the wind continued to blow. It actually sort of um, uh, while I was searching for Messier 65, the wind did die down a little bit. Right, it was slowly dying down. By the time I ended the live stream, it was actually pretty calm. It's pretty calm. So I'm like, okay, well, given how much trouble I've already had, I'm going to go over to my eclipsing binary star, HW Virginis, and get the telescope over there and this one I really want to get. So I'm just going to point over there now and get it. So I had done a completely new skyline, and I spent some time actually confirming that the pointing was better. So when I went over to HW Virginis, it literally took me 2 minutes to find the pattern, and then just a couple more minutes to move the telescope into place. And so I collected 200 4-second images, and as soon now, I don't think that the universe does this on purpose just for me, but sometimes it really feels that way. As soon as I started collecting data, as soon as I started collecting, the wind started blowing harder than it had all night. It was blowing really hard. Shaking the telescope. Hey there, Blackie.
Hey, here's my star puppy.
Yay. Star puppy. Uh-oh. Oh, there he goes. He's climbing. Over the shoulder. All right. So, yeah, it took me mere moments to find HW Ver, and so I just started collecting data. The wind started blowing hard, shaking the telescope, and now after spending an hour looking for target 1, I was just like this close from just having a fit, right? And so I start collecting data, and the wind starts just howling, shaking the telescope around, blurring the images. It's like, but I endured because some of the images were nice and stable, and I think
I'm really not gonna love tomorrow. It's gonna be storming tomorrow.
Storming over there, yeah.
Yeah. What about you?
I think it's supposed to either be high clouds or clear, either one. Not quite sure which.
Now you're close to Tucson, right?
Pretty close, yeah.
And I think what's also good about it is I got Google Assist.
Yeah, I'm east of Tucson. So I'm east of Tucson.
What's the weather at Tucson, Arizona? It's not, I don't think that you're going to have moist and stuff, but...
Okay, cool. What does that say? 70 degrees, partly cloudy. That sounds about right.
Yeah, I can... What's the weather in the morning for Tucson, Arizona?
Okay. Wow. It's getting warm over there.
Yeah.
Sweet. Nice. All right, so I got on to HW Virginis. Wind was howling, but I persisted because some of the images were okay, and as I think they were like 2-second exposures or 3-second exposures or something like that, and so I just I started at a certain time, and I watched the clock, and I collected data through what I thought was the entire eclipse cycle. And I was I was watching the star. I was watching it this whole time because it's a 20-minute eclipse. Okay, now I should be able to notice a difference in brightness over 10 minutes, right? It goes from bright to dark, back to bright in 20 minutes. So half of that time is going from bright to dark. So in 10 minutes, I should remember what it looked like. And so I was watching it, and I could not tell. I could not tell if it was dimming or not. And so, you know, I was collecting all this data, and there's this, you know, this little voice, right? I'll do it over here. Little voice back here saying, maybe that's the wrong star. Because, yeah, I guess I was expecting, you know, to see it dim and brighten over the course of 20 minutes. And it looked exactly the same to me the whole time.
Now,
And
out of my curiosity, have your parents ever also had interest in astronomy?
not to the extent that mine was.
Okay.
They realized early on that the best thing that they could do for me when it came to astronomy was just get out of the way. So that's exactly what they did. They're just like, have at it. Just have at it. We'll stay out of your way. So that was probably, that was one of the great things they did, for sure. Was just got out of my way. You know, I was at 14 years old. I mean, I'm thinking about this now. 14 years old, I was going to the back of back country. I mean, out in the middle of nowhere, with this group of guys that were twice my age, at least, if not more. So, you know, here I am, you know, this young kid with a telescope, and I'm hanging with these, you know, 30-year-olds, 40-year-olds, and older, and just having a ball. So that's an example. You know, they just sort of got out of my way, and you know, trusted me enough to realize that you know, this was the thing that I really wanted to do, and it's like, go kid, go. So yeah. Anyway, so yeah, I did not see that star dim at all. And so I'm like, man, I sure hope that was the right star. So I was really, really anxious this morning to get up and reduce the data and take a preliminary look at things. And so I will share that with you here. So none of this is written in stone. This is just a preliminary thing, just to show off to my great friends here. So let's see, we're going to go over here, and I think what I'll show you first is this. So this is just a long exposure. So it's all the images that were decent that I stacked. And yeah, actually, I have to correct. I think I took like 200 and about 240 images, maybe even more, like 260. I forget exactly. And because of the wind and because of the tracking, and the tracking was really, really bad. Remember when we were looking at Messier 46 yesterday, that scope was tracking so well that I could do a 10-second exposure and get round stars. I was blown away. I was looking forward
How bad
to
was the
last
wind
night.
anyway in yesterday's session?
It was bad enough that it was ruining ruining data. Let me show you. We can do this. Is that a good place? Yeah, it's a good place. Um, let's see. 402. Oh, you know what? I don't know why I did that. I just have to run this. I didn't have to do any of that because I just wanted to run DS9. I'll show you a wind damaged image. I should be able to find one here. So opening up DS9, I'm actually already there. So let's look for one. I'm not quite sure. Here's one. Got it the first shot. So let me fix this up here a little bit. See if I can fix it up in any way. Min max. Let's go to logarithmic.
Now this is just a messed up image, right?
This is just a messed up image. Let me zoom in a little bit here. So that's what happens when the wind blows. I've just got smudges. And, you know, this...
That actually means you got all that noise crap as well, huh?
Well, there's noise. There's always noise. Yeah. So that's a bad image. Let's find a good image. I think number 18 is a good one. So there's a good one. You can see the difference. it's well, significant. This is rescaled, so the amount of noise is exactly the same. It's just a lower level because the program is picking up on the fact that these stars are significantly brighter. So it's just having to rescale. But that's what it should look like, and that's actually what I used. I used this image as a template for all the others.
I'm also curious about the way you did the command for DS9. What was with that in sign for?
Oh, that puts it in the background, so I still have my prompt.
Okay.
Yeah.
Okay, that's cool.
So you can put a process in the background that way.
Okay.
Yeah. Or you can run a program. I'll just do this because that's easiest. And if you do a Control Z, you can stop it. It's just stopped in its tracks. I can go FG and put it back into the foreground, or I can do a BG and put it in the background. I don't know what that's going to do. It just stopped. Okay, so that program doesn't like to run in the background. That makes sense. It's a program that shows all the processes. So, oh yeah, Unix is a great thing. Anyway, so this is the template I use to stack.
Now, can you put a motion sensor on the telescope? It'll be better. That he says is better.
I think you're talking about a motion sensor. A motion sensor. Chuck, I'm not quite sure what you mean by a motion sensor. So yeah, clarify that a little bit. I'm totally into the geeky thing. Anyway, so this is a stack of of the acceptable images that aren't blurred out
Okay, to
by the
see if it
wind.
wobbles, etc.
Oh, I see. I see. Yes, I can guarantee because I've seen it visually. So yeah, yeah. That's just one of the things. That's why oftentimes telescopes are put into domes because if you're mostly enclosed, then a little bit of wind isn't going to affect you at all unless it's blowing right through the slit. But as long as you don't point into the wind, you're fine. There is no wind. So that is one of the advantages of a dome. Anyway, so here's the long exposure, and here's actually the target itself. So that is HY Virginis. Now this is a long exposure. So we're not seeing the light curve. I'm going to show you that next. But it's pretty cool. We've got some faint stars popping in here too. So pretty cool, pretty cool. So that worked out really well. And here is the preliminary light curve. So this down here is the Julian date, which is just a measurement of time. It's just one of the other ways that astronomers like to measure time. And then this is the relative magnitude. So what that means is that, and what I did is I used this star as a reference. So this is my reference star that isn't changing in brightness, and I'm going to compare its brightness to the brightness of the target star, which supposedly was changing brightness. And so what you get is, this is the difference in magnitude between the two. And so prior to the eclipse, HW Virginis was about 1.7 magnitudes brighter than the reference star. And then at its lowest, it was about 0.9 magnitudes brighter than the reference. So, but as you can see, I caught it. I caught the whole thing. It's about that level over here and about the same over here, more or less. It's it's a little noisy, but it's not really too bad. So I think that went really well. I was a little bit concerned that I wasn't actually going to get any data on this at all because of the wind, but I got a substantial amount, a usable amount. So pretty cool. I will. What I now have to do is I have to transform this data into Johnson V magnitudes. V is in violet. This is the G in the RGB filter scheme, and so I have to convert G to V, and that's just a transformation. I calculated the coefficients I need, and so I just have to do that, and then this will be this gathering of the data at least will be done. But I think that's pretty sweet.
I think you're being held by a cat.
Yeah, I can hear him. Oh, okay. No, I think he can. I think he can stay out. We'll see if I have that kind of choice or not. Anyway, so yeah, I think this looks pretty good. Pretty pleased with that. Would have had about twice as much data, almost twice as much data, if the wind wasn't blowing. So, you know, this would have been filled in a lot more. But as it is, you know, I can work with that. So pretty neat. It looks pretty symmetric. All right, I'm gonna go let him in. Hold on a second. Come on. Hi. Hi. Yeah, we're looking at H.W. Virginis. He just wanted to see this light curve too. So I don't blame him.
Yeah, and my dog is sleeping.
So yeah, I'll have to, you know, I've located and actually I'll show you that too, I guess. Let's see, can I? It's called the Phoebe Project. And this is a piece of Python software that is specifically for the modeling of eclipsing binary stars. So I'm going to install this, and I think, you know, I think the study of eclipsing binary stars, for some reason, it seems a little bit interesting. So as I said, I'm going to go ahead and install this and start working with it. It's you know, this is modeling software, so there are I think at least dozens of parameters that can be messed around with and all that. I actually, yeah, do I want to get into that? Yeah, you know, there are some papers that actually describe. Oh yeah, let's take a look. There's this one. So this is just sort of an overview paper. So this software has actually been out for quite a long time. This thing was published in 2005. So it has been around for quite a long time. And Slovenia, very cool. Very, very nice. But this allows you to model eclipsing binary star systems. You can specify, you know, the types of stars that are the two components. You know, the orbital period, the distance between them, their relative masses, lots of parameters, lots and lots. And what you end up with are these light curves. And you can take data like this. Whoop, where is it? Oh, I'm lost. You can take data. Yeah, there we go. You can take data like this and actually tweak the parameters around. You know, the program will iterate, and it'll mess around with these parameters and generate light curves that actually best matches this data. And then you look at the results and say, hey, it looks like, you know, it's these kinds of stars with these kinds of masses, this kind of period, you know, all of that. Now, from this, I wouldn't be able to get a period. I've got to collect got to collect another data set like this, and then I can stitch the two together, and I can get a period that way. But anyway, so yeah, I'm going to dive into this code a little bit. It looks like it's very mature and
How
awesome.
about like we'll like to wait to see it in action, like right now and stuff, or what do you think?
Oh yeah, no, I'm going to have to jump onto the learning curve first. And that is just ugly. I don't think anybody wants to see that. but no, I will definitely keep you updated on this because yeah, I definitely want to get to a point where this code is looking at my data, and that data is feeding a model for which I can actually get some parameters about about this system, and I can see how closely it resembles measurements that have been made in the past. This is a very well studied object. I think we were actually looking at this the other day, that it was discovered back in 1986, and yeah, it's really interesting. The components are two dwarf stars. One is what's called a subdwarf, which is the core of a red giant. So
I hate it when work gets in the way of a live stream on Astro. And welcome, by the way.
Our Instro's here. Cool. Nice to see you.
Yeah.
Yeah, that's how it goes. There we go. Oh, you can't really see that very well. There we go. So yeah, I at least want to get to the point where that code is looking at this data and can give me some information based on the model, what it does, and it's nice. This code is all open source, and so I can actually go into the code and see exactly how they're doing all these things, and yeah, should be interesting. But that's a nice curve. I think that worked out really well. Really well. So it's all preliminary though. So I've got to make sure that I did this exactly right. I mean, it looks good, but oftentimes looks can be deceiving. So all right. Well, cool. I think that I am actually going to get out of here for now. Yeah, I think so. I think it's about time to exit this planet. Let's see, was there anything else that I wanted to show you with the images? Can't think of anything. There's the stacked image here, which we can sort of play with a little bit for a minute. One thing that I noticed right away is that this slope is back. See how it's brighter and then it goes darker. So there's, I'm not quite sure what is going on there, but as I said the other day, I think it's a systematic of some sort. I'm pretty convinced that it's not the sky. Yeah, that doesn't make much sense. But so yeah, it's got to be something within the system somewhere, somehow. Um, maybe it's the stacking code. It's extremely subtle, extremely subtle. I don't know if you can see the numbers up here. There's a thing that says value. And when I move over things, you can see numbers. And if I sort of scan around here, I'm seeing maybe an average of about 2. And if I scan over here, I'm seeing an average of about 1.5. So it's really subtle. But it's, you know, when I'm doing photometric measurements, I'm counting, you know, the values of pixels, and I'm adding them. So, you know, any contribution here is going to be slightly biased higher than here. And these are the 2 stars that I'm measuring. This is the eclipsing binary, and this is the reference I used. And as you can see, it's in a brighter portion than here. So there's a little bit of a bias there, and I don't like it. So I'll just continue, you know, to think about that. Try to understand, you know, what the cause is. Try to understand if I should be worried about it. Maybe it's so small of a thing that it just it's just part of the noise, right? If this effect is just, you know, somewhere in the noise here, then I don't care about it. I've got bigger fish to fry.
That's it.
That's it. All right. Well, speaking of bigger fish to fry, I definitely think I'm going to get out of here now. So, all right, everybody, take care. I think it's supposed to be clear tomorrow, but I don't know. I don't know if I'll do a live stream from out there or here. You'll just have to be surprised. I know I will. so yeah, I won't know that until probably.
What's the weather for Tucson tomorrow evening?
There we go. It's supposed to be clear. Okay. Well, it says clear, so we will see. We will see. We're coming up to new moon. I think new moon is very soon. Speaking of which, the one thing that I need to do either tomorrow or the next day is we've got to go through our April events.
Yes.
Right?
Why
yes.
We have yet to see that yet?
I know. I'm being a slacker. I should have done that today. But no, I had to talk about all my cool stuff. All right, everybody. Well, I'm going to get out of here. I think I think that fact has convinced me that we will do a live stream right from here. We'll take a look at the April astronomical events, and you know, we'll talk about them. There's always some tangents there. There's always you know, something it's like, oh, you know, let's investigate that a little bit more, or you know, whatever. So so yes, tomorrow's live stream is a very rare planned event, and that'll be that we will go over to Cloudy Nights, and we will get on to the April calendar and see what's going on this month. I know that new moon is tomorrow, so the 5th. So, but that's all I know. I think the Lyrids. I think the Lyrids are coming. So, but we'll check all that out.
Lyrics.
Can't wait. Can't wait. Okay, everybody, take care. Peace, cheers, and all that. And I will see you later. Have a great evening and a great day. See ya. Bye.
Live long and prosper.